Hello everyone, welcome back to another GIS Mathematics lecture video. And in this lecture video I want to take the same idea of A and B, but I want to flip it around and I want to do B times A. So we're going to give ourselves a little bit of space and we're going to copy, actually you know what I'm going to do? I'm going to actually copy this and bring it with me, at least for a second, so I can copy it down, save myself the headache of having to look back and forth. All right, so we have A is going to be this matrix here, right? 2, 6, 6, 2, 5, -1. We have B as this matrix, -4, 5, 0, -4, 4, -4. Okay. So now I can erase that. Okay, so in this example, right, in the previous one we did A times B. Now I want to do B times A. Right, and if you read the chapter, or if you listened to some of the videos, right, I said that matrix multiplication is not commutative, which means B times A does not necessarily equal A times B. And so B times A is going to give us a completely different answer. And what I want to do here is I want to think for a second. All right, what are we going to get if we do B times A? So just like always, you want to set your matrices up. So the dimensions of B, again, 2 rows, 3 columns. So that's going to be a 2 by 3, right? Again, 2 rows, 3 columns. A is a 3-row by 2-column matrix. So that's a 3 by 2. Right? These are the same matrices from before. We've just changed the order that we're doing the multiplication in. So as always, the first thing you want to do is you want to check whether your inner dimensions match, right? Does this 3 match this 3? It does, so we're good, so we can continue the multiplication. The next thing we do is we look at the outer dimensions. So we know that BA is going to have 2 rows, right? That's where this is coming from. And it's also going to have 2 columns, right? That's where this, right? This is where that's coming from. So we know that if we do B times A, we're going to get a 2 by 2 matrix. So we already have a drastically different answer, right? If we scroll back up for a second, right? When we did this before, right, we ended up with a 3 by 3. So A times B was a 3 by 3 matrix. B times A is actually going to give us a 2 by 2 matrix. Okay. So what I want to do is I want to show you why I internally organize myself in terms of these unknown x's, right? This is the same thing I did before, where I fill the matrix up with these imaginary unknown x's, and then I give them subscripts based on what position they're in. So this is still in 1, 1, right? It's row 1, column 1. This is in row 1, column 2. This is in row 1, this is in row 2, column 1. And this is in row 2, column 2, right? Again, all I've done is I've put these imaginary placeholders and indexed them based on where they are in the matrix. Hopefully you followed along last video. Hopefully you can follow along this video. Okay, so now what we can do is we can treat each one of these independently. And we can say, well, what is x, 1, 1? What do we do here? So this is the reason why I wanted to do the backwards, because it not only does it change the shape, but it also changes which rows and columns we go for. Right? So in this case, right, the 1 here, right, that still means grab the first row of our first matrix. But if we look at what we're doing, right, our first matrix in this case is actually B, right, because it's B times A. So B is our first matrix. Right, let me make a note here, right? This is our first matrix. This is our second matrix. All right, so X subscript 1, 1 says grab the first row of the first matrix. So what we're going to grab here is actually this one. Okay, and then it's saying grab the first column, right? Grab the first column of the second matrix. Well, the first column of the second matrix is this one right here. Right? So what have we done? Right? Again, we've created a column vector times a row vector. Row vector. This is a row vector times a column vector. Right? And we know how to handle that, right? It's the exact same thing we did before. This time we just have 3 numbers instead of 2. So this is going to be -4, again, coming from here, times some number, right? Plus 5 coming from here, times some number, plus 0 coming from there. All right, well, what are these? Oop, I put my equal sign way too close to that 0. All right, so what goes in these spaces that I left? Well, that's going to be the values in this column vector, right? 2, 6, and 5. And we can do the math. -8, 30, and 0. That's going to be 22. Okay. So now we know, right, that x11 is going to be 22. Okay. So now let's go with the upper right here, this x12. All right, so what is this saying? This is saying take the first row of our first matrix. Right, so again, that's going to be this one here. Right. So let's pull those values out again, right? -4 times some number plus 5 times some number plus 0 again times some number. What number are we going to put in these gaps this time? Well, we're going to be looking at the second column, right? Because this is a 2. We're going to be looking at the second column of the second matrix. Right, so that's going to be, right, this bad boy right here. Right. So what are we going to pull out, right? The 6 is the first element, the 2 is the second element, and the -1 is the third element. Right, now we can do the math again. Right, this is going to be -24, this is going to be 10, and this is going to be 0, so we're going to get -14. Right, so we know that x12 is going to be -14. Okay, so we can do this again. Right now we can look at the lower left, which is going to be x21. All right, again, I'm actually going to highlight this because I want to make absolutely clear. Right, in this case, right, x21 means we're going to grab the second column, right, the second column of the first matrix, right, that's going to be this right here. We're grabbing the second column of the first matrix. That's what this 2 in the 1 spot means. So we're going to pull those values, right? -4 times some number plus 4 times some number plus -4 times some number. So what's going to go in these spots? Well, right now we're looking again, right? We're looking again at this 1 here. This 1 is saying grab the first column of the second matrix. And that's going to be this bad boy right here. All right, and so if we do that, right, we're going to be pulling the 2, because that's the first element in that. We're going to be grabbing the 6 because that's the second element in that, and we're going to grab the 5 because that's the third element. And so if we do the math, right, that's negative 8, that's 24, and that's negative 20. If we do the math on that, we should get negative 4, right, because that's negative 28, that's 24, you should get negative 4. So we know that x21 is going to be negative 4. Right, and then we can wrap this up by looking at this matrix indexed at 2, 2. So let's take a look at what that means. And we're going to do, let's do red, because we haven't done red yet. Right, so this 2 right here is saying grab the second row, or the second row of the first matrix. So that's going to be this again. Right, the second row of the first matrix. So we can pull those values out, right? Negative 4 times some number plus 4 times some number plus negative 4 times some number. Though the number that we're going to be putting in those gaps, right, is going to be the second row, or sorry, the second column of the second matrix. It's going to be this right here. Okay, right? So we start pulling numbers down, right? The 6, because that's the first element in the second column. The 2, because that's the second element in the second column. And then the negative 1, right? And so if we do the math, right, this is negative 24, this is positive 8, and that's going to be 4. So we do the math on that, we should get negative 12. Right? Because 8 and 4 is 12, positive 12 plus negative 24, negative 12. Right? And so we do that, and we are done. Right? We've taken a 2 by 3 matrix, multiplied it by a 3 by 2. We checked the dimensions, got an output that is 2 by 2, and we can use these subscripted x's either written on a paper if you need to do that, or like I do it internally, just to keep track of what you're multiplying together to make sure that you get consistent results. Hopefully these 2 videos clarified things. If you have any questions, please reach out. Thank you.